everybody. This is our lesson, continuing with lesson 21. Now we're going to take our idea of scientific notation and we're going to compare values. The whole point of scientific notation is that we don't have to be so concerned with counting zeros. And is it 8 zeros or 7 zeros? It already tells us in the problem. Now we're looking at how much bigger or smaller is something based on its scientific notation. So first, I want to go over, and I'm just using the working page of my notebook, why some things are larger or smaller. So, same number of place value. Remember, place value is super important in this. So we have 4 zeros, okay, 10 to the 4th power on both sides. So now we look at it and we just say, well, duh, I knew that 6 was bigger than 4. How much bigger? Well, 6 divided by 4, okay, 3 over 2. 1 and 1/2 times larger. Okay? So the place value is the same, but my leading number is bigger, so I know it's 1.5 times larger. I can make the comparison. Okay? Here I have the same leading number, but this value is different. Okay? -2, the exponent -2 in front of a 10 is 1/100th. The exponent -7, 1, 2, 3, 4, 5, 6, 7. Okay? The second one is larger. The first one is smaller. Okay, how much smaller? Okay, well, what is 10 million divided by 100? $100,000 times smaller. And notice I'm basing it on the very first one. This one is smaller. This one is larger. So I'm reading the expression left to right. Okay? And notice how just by comparing what's different, I can determine, well, my gosh, that's way smaller versus my gosh, that's way bigger. Okay? And for different things, you would want different things. I'm not saying one's better or worse. So let's look at another. What if I have, again, same leading number, but different exponents? This is saying 1, 2, 3, 4, 5, 6. One, two, three, four, five. 600,000 versus 6 million. Notice for every time this exponent changes, you're going up or down, okay? Not always up or down. 10 or depending on whether it's up or down. So This first one is 10 times larger than the second one. Okay? So we're determining which one's larger and by how much. But what if nothing matches? That doesn't match, and that doesn't match. It's a lot easier to do when one thing matches. So let's take a look. Okay? I could change the exponent by simply knowing that I'm multiplying by 10. So I could write this again, 7 times 10 to the 6th power versus 50 times 10 to the 6th power. So that times 10 that happened right here is reflected. Well, now I'm going to say okay, 50 divided by 7, okay, that equals 7 and 1/7. So it's about, that squiggly equal means about, 7 times, 7 times smaller. Okay, and notice, reading left to right, this guy is smaller than the, so this is what I'm talking about. For your purposes, you're going to want to use maybe colored pencils, maybe a little note to yourself of which thing you're comparing to the other so that you know smaller versus larger. Okay? Now, let's look at a couple word problems that'll help us with this. Okay? 4th of July fireworks. The people planning 4th of July fireworks in City A expect 3 times 10 to the 5th power people to attend. Okay, they're not going to say how many people that is, they're just saying this many people. The people planning in City B expect this many people to attend. Which city is expecting more people and how many times more? Well, 30 times 10 to the 4th power. So notice I had 3 times 10 to the 5th power. 1/4, or 10 to the 4th power, okay, I took 10 times 10 away from it, so I put it back here with the 30. Okay, so these are equivalent. And that equals 300,000 people. City B, okay, is already in the 4th power. It equals 60,000 people. Now, you could calculate it all out and then see how many more times. That is perfectly acceptable way to do it. Or, okay, you could take the fact that 3 divided by 6 equals 1/2 times a 10 difference. One exponent is 10 value places. 5 times more people. So I can calculate it all out. There's nothing wrong with that. But depending on how big your numbers get, could it get cumbersome? Or I can say, oh, well, the difference here, 3 divided by 6, that's 1/2, times a difference in exponents, of 110, just 110, 5 times more people. Okay? What if we get negative exponents? Then what? So let's look at hair. Now, this might be something that people might do at a vet, or if they're studying a trail and what things have been along a trail. A deer's hair has a diameter of 4 times negative 10 to the 4th meters. A dog's hair has a diameter of 8 times 10 to the negative 5th meters. Side note, if you're actually doing this in real life, switch to millimeters. It'll save you some of the scientific notation, but that's not what we're doing right now. Which animal's hair has a greater diameter? How many times as great? So this one is 4 times 10 to the negative 4th power. This one is 8 times 10 to the negative 5th power. Okay? So I could change this to be 0.4 times 10 to the negative 5th. Notice, by giving it another a negative tens value, I moved the decimal that way. Versus 8, and this is still 10 to the negative 5th. 0.4 divided by 8 okay, with no difference in here. Okay, now which one is larger? Well, the one with less exponents is going to be smaller by a decent amount. Okay, this is 5/100ths or 1/20th. Okay. So which animal's hair has the greater diameter? Okay, which one is bigger? Well, let's double check our work. 4, negative 4. 1, 2, 1, 2, 3, 4. Okay, that's deer. Versus 8, 1, 2, 3, 4, 5. That's dog. Okay, so your deer hair, which makes a lot of sense because your deers are living outside. Okay, deer is 20 times larger, or dog is 1/20th of deer. Okay, so make sure, let me switch this up. There we go. Okay, move me as well. Make sure that when you're finishing these problems, you've done the math. You understand that it's this versus that. And you can just compare them that way if you want to. But when you're comparing which one's larger, really look at it. The deer hair is a lot larger because look how many less place values it is. Okay? Tenths, hundredths, thousandths, 10,000ths. Tenths, hundredths, thousandths, 10,000ths, 100,000ths. Okay, so please make sure that you're really looking at that with critical thinking skills. Hopefully that helps. We'll try some in class. I can't wait to see you guys again.